We're expecting a number of people, so welcome. I'm really excited for today's session. Excited to see you all here. While we're waiting to get started, Carol, would you mind advancing to the next slide, please? If you wouldn't mind saying hello in the chat. Also, if you can, go to your square, your Zoom square, and rename yourself. Just put your name and your country or your role. I need to do that as well. And if throughout any of this, if you have any tech issues, go ahead and send us a message if you have any challenges. Just also one other reminder, Carol, would you move to the next slide, please? Just a quick reminder just to be courteous and respectful, professional in your interactions with folks. We're going to have an opportunity for some discussion later on. So these were some norms of engagement that we had implemented during the annual meeting. So we're just continuing with those for these learning sessions. Next slide, please, Carol. So welcome all to this session. Today we're focused on snow, on two projects, X-Snow and Blowing Snow. We're really excited to share and to connect with these two projects. And this session is part of a wider set of sessions that are designed to enable the Globe community to learn together, to come together and deepen connections, to hear from each other. So we're really excited for today's session. I just want to mention that there are several other sessions coming up. One that extends our member recognition that began during the annual meeting. Another where we will hear from science activation projects, so several projects that are also using Globe data that are funded separately by NASA. We'll have some sessions on alumni. There are two more of those coming up. One will be in December, and we're going to share highlights from all of Globe regions. We'll have another session in the new year focused on lake observations as well. That will be really interesting in thinking more about connections to other citizen science efforts. And then some updates on training and protocols. So look for more information on that. All of the recordings from our past sessions are posted on the website. And our plan is once we can, we will post recordings from this session and other sessions, and all of the registration information from the currently planned sessions are up on the website as well. So keep a lookout on the website and register for those sessions when you have a moment. Next slide, please. Just a brief overview of today's session. Christy will give us some introductions. She'll introduce our two speakers, Marco and Bill, and we also have Jen Delamere here as well from Blowing Snow. And then, as I mentioned, we'll break into small groups or smaller groups after those two sets of presentations. And at that point, we can have some questions and answers for the two different groups. And our goal is to explore a little bit more deeply the connection between Globe and those two projects. And so we can think together about what some next steps are and how we can continue learning from each other and building on each other's work to strengthen what we know about snow. And after those two groups, we'll come back to the big session, and we just have two quick wrap-up items at the end. And so with that, I will hand it over to Christy.
Hello, welcome everyone. I'm Christy Buffington, the Deputy Director for Training, Education, and Public Engagement for the Globe Implementation Office. Also a Science Education Director and Program Manager at Geographic Information Network of Alaska, or GINA. And this is at the University of Alaska Fairbanks Trothyeta campus on the traditional homelands of the Lower Tanana Dene people. So thank you everyone for coming. It's a snowy morning here in Alaska, so it's a very appropriate time for us to talk about snow, both on the East Coast with the X-Snow project. Dr. Marco Tedesco, who is the principal investigator or PI of the X-Snow project. And then Bill Line, who is a NOAA civil servant. So he couldn't be here, but we have a recording of his presentation about blowing snow. Just a quick story about this. Blowing snow conversation or pilot project started in a webinar, much like this one. Bill Line was presenting at a VAWS or Virtual Alaska Weather Symposia webinar, and I noticed that he had some photos from people who had collected observations and also webcams. And that led to a conversation saying, hey, do you think you could use crowdsourced photos of blowing snow, or when the sky is clear and there's a wall of snow ahead along the horizon? He said, yes, absolutely. So that actually started this conversation that became a pilot project. So you never know what can come of people gathering like today. So first I want to introduce Dr. Marco Tedesco. He's a Lamont research professor at the Lamont Doherty Earth Observatory of Columbia University, and also an adjunct scientist at the NASA Goddard Institute for Space Studies. And he also has been engaging people all over the world, from Italy. We're at the Santana School of Economics, also a resident scientist at Columbia Business School for the past several years. And he earned his PhD in Italy from University of Naples, and has spent 5 years as a postdoc and research scientist at NASA Goddard. And then also moved to CCNY in 2008 in New York, and has been a professor there as well, and has founded the Cryosphere Process Laboratory. So that's a lot. I'm sure I can give you more about Dr. Marco Tedesco, but he's very inspirational because the time I've spent with you, Marco, you get people fired up to go outside and observe snow. So I'll give it over to you. And then after that, when it's time to play the recording from Bill Line, I'll give a quick introduction to him. Thanks, Marco.
Thank you, Christy. You're too good. Can you hear me properly?
Sounds great. Thank you.
Thank you. We can start maybe with the next slide so that we can frame. Thank you, Christy, for the introduction. Actually, I start as my 25-year career has been focusing on melting of Greenland. And now I've been also looking for the past 10 years on climate justice. And I got closer to the citizen science because also my PhD was on snow hydrology, which I've been doing also for the past 30 years. Thank you for the introduction. I want to thank, let's move to the next slide, please. I wanted to thank my, what I call the health PI, which is not a co-PI, but Margit Turin. She's a component and educational and outreach director at Lamont. And without her, this would not be possible. I'm not just using words that are made, but really, this was an amazing partnership. And Marisa Annunziato is helping with with Margie, and Patrick Alexander was originally involved in X-Snow. Next. So first of all, why do we call it X-Snow? Next slide, please. One of the idea I had was in 2000. Let me just start my timer. Sorry, so I know that I'm taking more time than I have to. Everything started basically about in 2017 when I felt the need to go not to Greenland to collect some of my data. I remember that my background was in snow hydrology. So I've been also the lead PI of the NASA snow product that produces global maps from space, and I felt the need to develop more and more tools to validate the remote sensing products. So long story short, I spent 3 or 4 years trying to go around the Catskills and collect people so that they could help us, but there was no call for the citizen science in terms of snow or earth sciences. So COVID happened. Then the program reopened. We saw the opportunity. We submitted this proposal with Margie based on the X-Snow that we originally did. And the idea of calling X-Snow is because I think everybody has the power to help us in identifying snow. So it's a little bit like X-Men, X-Women, to have X-Snow powers, and people like this idea. So we started the past December. So we were actually funded in the middle of the snow season, and we were able to only start to have connections and training. And we're actually now getting ready to do further training upstate and start the data collection. So if anyone is interested in helping with networking or collaborating, I put my email also in the message list, and this is the right time to do so. So why, I'm not gonna tell you the importance of snow. Everybody knows how important is snow. I just wanna remind you a few things. Snow melt is of course incredibly important for freshwater management resources, for drinkable water, for regulating the hydrological cycle of our land. It also controls the climate system through the feedback of the radiation that it bounces back. Also, I don't know how many people know about it, but if you look at the top left box, snow is also a very highly insulator. If you have a snowpack covering your tree and the temperature go below zero, below the freezing point, the tree will be protected by the snow, where if you don't have snow, the tree will be basically exposed to a big hazard and with the risk of a lot of stress. Also, 98% of the Earth's snow cover is actually in the northern hemisphere. So we are exposed and we are feeling the effect of that. Next slide, please. So why X-Snow? Why on the East Coast? And X-Snow, of course, the East Coast is currently underrepresented in terms of data collection with respect to the West Coast snow. And this is really historical, financial, cultural. There's been a lot of investment from NASA and other centers to focus on Alaska and the West Coast because, of course, there's a thicker snowpack, it lasts longer. But on the East Coast, the snow is different and from the one on the West Coast. And whatever we learned or we can collect or we know about the West Coast snowpack, it's not going to be really applicable to the East snow, to the East Coast snow. So we can not rely on anything that has been produced so far, and we really have to focus on looking at what we can learn from the East Coast snowpack evolution. Of course, on the East, we have impacts on commercial activities, we have water resources, and validation of models and remote sensing products. Besides, I think on the Catskills and Adirondacks, where our project is focusing, there is an incredible need to feel helpful when it comes to snow. They live the snow, they are there, it's their home. It's part of their cultural background. And I think this project is giving the opportunity to those who want to help to focus on this. Next slide, please. Can you start the video yeah. So this is basically one of the products that is generated from space that it's validated. You can see now this is optical, but in reality, we can make the snow cover, we can look at the snow depth, the grain size, the temperature of the snow, but of course, satellites are not perfect. And how well are we performing and how much can we improve every time is extremely important to refine and reduce the uncertainty. This is true for now, and it's also true, very important for projecting what's going to happen to the snow in future climate change scenarios, because again, for thermal properties, for drinkable water resources, for management resources, for the ski industry, everything is important, understanding how snow will evolve. Next, please. So this is important. I'm not gonna, let's keep this slide because I think I already made enough case and I wanna focus more on the, thank you so much. So we cannot be everywhere, anywhere. I mean, satellites, drones, they can help us to give a big picture. The snowpack is behaving like this, but imagine that from space, the box that you can see, the pixel size resolution, in the best case scenario, when you use cameras similar to the ones that we have on iPhones from space, which, by the way, there are cameras shooting pictures at 100 kilometers up in space, and they're able to pinpoint down where you are, which is, to me, incredibly still fascinating, the way remote sensing works. And then you can zoom in and you have 10 meters pixels, you have 20 meters. So what you're saying is, imagine a cell phone that gives you only images that are relatively coarse. In some of the sensors that we use, goes up to 20 kilometers. We are able to cover big areas, but we pay the price of being the images more blurry. We can combine everything, but we still need to be on the ground to understand how things evolve, how are models doing, how's the satellites looking at this snowpack, and what is the relationship between the snowpack properties and the electromagnetic radiation that the satellites measure, so we can discover new things, we can understand better the processes, and we include this into the models. And of course, we cannot be anywhere. We cannot be anywhere, anytime. And we need this data to be very dense. And this is where the XNO people come, right? This is exactly where people can help being there. And this is the basic philosophy of citizen science. Next, please. So what are we going to measure? What are we going to ask people to measure? There is the first quantity that I wanted to briefly describe is albedo. Albedo, we know very well what it is. Even some of us might not know the name. Albedo is basically how much light is reflected back by a material. If you're wearing a black shirt like the one I'm wearing and you're in the sun, you will absorb a lot of material, a lot of energy. And if you wear a white shirt, you will reflect a lot of it. So you are warming up much faster with a black shirt, of course. Same with snow. Water is or other elements. Water is very dark. You can see has a very low reflectivity, means that only 3% of the energy is reflected, but 97% is absorbed. The forest is still dark, then you have sand, and then you have the snow, which is very bright. So the albedo is a function of how old the snow is. What are how fresh is the snow? Did it melt? Did it not melt? So all this information is incredibly important. Next, please. And it's connected also to the other parameter that we care about, which is what's called the SWE, the snow water equivalent, which basically tells you how much water there is in a snowpack. If you take a snowpack and you put into a bottle, once the snow melts, how much water is going to be in your bottle? The denser the snow, the more water will be. The less dense and fresher the snow, you will have less water. Why is this important? Clearly because this gives us the measure of how much water there is in the snowpack that can be used for hydrological purposes, for drinking purposes, for management purposes, and so on. And so this is the hardest part to measure, because the snow water equivalent, as you can imagine, is the volume basically of the snowpack, and it's given by the depth, so how thick the snowpack is, and the density. So once you multiply the density for the depth, you got the volume. Now the density is very hard to measure, and also it changes with the vertical profile. You have a snowpack that has been deposited, let's say 3 weeks ago, that has been metamorphed and have large grains, and maybe went through melting cycles, so the density started to go up. But then you have a new snowpack on top of it, fresher snow, whose density is very small. And how do you calculate these two without measurements from space? It's one of the greatest challenge, and this is exactly where this kind of measurements can help. One aspect that is also important is that despite we look for the snow water equivalent, which we want to have density and snow depth, having only the snow depth, which is one of the easiest parameters to measure in terms of snowpack, is also incredibly important, because once we have the snow depth, we can constrain the other parameters and we can actually estimate the average density of the snowpack without the measurements, because having the snow depth allows us to basically pinpoint the area of the solution that we're looking for, and we are sure, we can be more confident that the variables that we're estimating are the ones that are actually in the snowpack, rather than something that could not be related to where we are. Next, please. So We have 3 different tiers of sampling based on the different skills. The first tier is, again, and one of the conversations, of course, I want to have with the Globe people and with everybody else, we're trying to standardize the measurements. We already have adopted some standard measurements for pictures, for example, together with the cloud and forest people, so that we can coordinate in terms of metadata creation, being more discoverable, access our users or our stakeholders to access other information from other groups. So the tier 1 involves only measuring the snow depth. We ask people to stick a ruler or something into the snowpack, take the picture, of course, with the latitude and longitude. We also ask them to give, if possible, snow temperature and do wetness and dryness with a fist, with a very basic, squeezing the snow and see if it sticks or not. But also we ask them to take the pictures for the 4 cardinal directions, north, south, west, east, up and down. And this is consistent with other groups that are looking at clouds and vegetation. Next, please. So this is the basic thing we're asking people. The tier 2 is something that requires slightly more time, but it's not extremely complicated, and it has 2 phases. The first part basically repeats the tier 1 in multiple locations. This is important because, of course, you can sit nearby a tree where it's protecting them from a blowing snow, just to introduce also some of the topic for the next talk. And then if you're measuring the snowpack behind the tree from a wind position, you will have more snow than, standing in front of the tree, you will have more snow than behind the tree that is protecting from the blowing snow. So we ask people to have multiple measurements within the area. And also, if possible, we have to take pictures with an app and to calibrate with a card so that we can estimate albedo and eventually take pictures of snowflakes. The snowflakes are connected to albedo. Some media in the past has been reaching out because they're wondering if we can actually connect the changes in the shape of the snowflakes that are falling to the changes in the atmosphere to understand how climate change is impacting snowflake formation in the sky. And this kind of information might be helpful also in this regard. Next, please. I will skip this. The snowflake images are basically taken on a ruled card, which is, you scoop it there. And then we have the tier 3 sampling. Tier 3 is really for those big, snow aficionados and those who love it, where you can dig a snow pit and you start performing measurements of density through special toolkits that we give you and other properties, taking pictures of grain size and so on, along the vertical profile. Now, that picture is very rare for the Catskills. You need to have a lot of snow. And for this tier, I'm not sure it's really convenient for the Catskills because the kind of snow you have is really coming, going. And then if it sticks, the snowpack is relatively thin but thick. So it becomes kind of hard. But this is actually the best measurement from a scientific measurement that we could get for validation purposes, even though the first 2 are probably providing 80 or 90% of the benefit that this technique can bring. Next, please. We also, of course, have drones that we fly. We have we have multispectral. And next, please. The way we use drones also, if you can start the video, it's very, I'm gonna cut it off, but this is a flight that we did a while ago. But what we do, we use photogrammetry to basically create maps of snow depth. So we have 3D, we can create 3D maps of everywhere the drone is flying. And so we can calculate the snow depth and compare the snow depth with respect to the measurements that people are giving us. Next. We also have developed AI-based tools in which we use web camera images to detect the snow depth. We're actually applying this to the Mesonet data station, in which they do have cameras. And they do also, we are asking, collaborating with the Catskill Center and others, they have camera to share the images with us at any point or continuously. Of course, we are very careful about privacy. But we have to, and I apologize for the messages. My postdoc has decided to blast me with all the messages. We are actually trying now to coordinate with others to apply these techniques. And these are the same techniques that we use for the tech flooding. We could apply them and evolve them to combine it with vegetation, with other projects. I found this aspect extremely fascinating, with the caveat of focusing on developing and applying ethical AI when it comes to data transparency and energy consumption. So next, please. We are also asking people finally to collect snow as it falls using jars. So we're asking them to put the jars open as the snow is falling and then collect snow, scooping them from them to understand how much of the microplastics is actually depositing from the snow falling. This is something that would be very interesting to look at together with the Blowing Snow project eventually, and how much is actually deposited after from atmospheric deposition given the relative location. There's really nothing that we know about how microplastic evolves, deposits in the Catskills, and it goes into the water, it goes into the streams, it goes into people's lives. So this is something that we care about very much, and we're hoping to get a lot of participation. Next slide. So these are the questions that I think Christy and Jackie also wanted to have for the breakout session. I am going to leave the slide here for a second. I'm pretty sure that they will probably share them with you. Next. And again, reach out, please. I'm here for the next, for this conversation, but also we are in the phase of building up more team, traveling upstate. If you want to join us, flying the drone or coordinate for data and metadata production is extremely crucial. I took 17 minutes. Thank you so much, Christy and Jackie, and I apologize for running over.
That was really great, Marco. Thank you so much. I would love to talk with you more about all the connections and that we have between your XSNOW project and GLOBE. GLOBE also measures snow as one of our many protocols. It lives under the solid precipitation part of the atmosphere protocol within GLOBE, and does have both snow depth and snow water equivalent for both the entire snowpack, for all of the snow that's been falling over a season, yet also using a white reflective snowboard, people can get the new snow. So it takes more of a meteorology approach than the land cover approach that many snow scientists might think of with snow cover. And then also, like you mentioned, you take the 4 cardinal directions of photos up and down. So does GLOBE within GLOBE Observer. So when it's time for breakout rooms, I absolutely encourage people to go to the XSNOW breakout room to see how GLOBE participants could participate in your XSNOW project. So thank you so much. That was a fantastic presentation. And now I want to, and I'll put in the chat some acronyms because and I also put the introduction for Bill Line. So sorry that Bill could not be here today because he is a physical scientist with NOAA and he is furloughed right now. Also, if you're, from outside of the United States, I'm going to say some acronyms. So do look in the chat for what these acronyms mean. He is at NOAA NESDIS in Fort Collins, Colorado, and is the STAR Imagery Science Team Lead. In his position, Bill collaborates with researchers at CIRA, Cooperative Institute for Research in the Atmosphere, and also operational forecasters. So what does he do? He conducts satellite-related research to develop imagery-based products and also best practices. Some of those imagery-based products is a blowing snow satellite data product that you're going to hear about in his presentation. And just like Marco was saying, we need people on the ground to validate these products that are made from satellite remote sensing. And previously, Bill Line was a forecaster with the National Weather Service in Pueblo, Colorado. So I will turn it over to Bill's pre-recorded presentation that he did this summer to the GLOBE Program Office and the GLOBE Implementation Office when we were just having these discussions about starting this new pilot blowing snow program within GLOBE.
Just a quick crash course on what we're doing with NOAA satellite imagery with regards to blowing snow, how it works, and kind of what we're looking for from you guys. So just in case you're not as familiar with our GOES and JPSS satellites, this is what weather forecasters use in the Weather Service to detect thunderstorms, blowing dust, hurricanes, sea spray, etc. From GOES, we have the Advanced Baseline Imager. It's a 16-channel imager that has from 0.5 kilometer to 2 kilometer resolution. Over the CONUS, we have 5-minute imagery all the time from these satellites. Over the rest of the full disk, it's 10-minute imagery. So over Alaska specifically, they get routine 10-minute imagery from the GOES West satellite. But we also have these 2 mesosectors that collect 1-minute imagery each. One of which has its default position over Alaska. So they do get 1-minute imagery over much of the region in Alaska a lot of the time. The other type of NOAA satellites forecasters use with respect to viewing imagery are the JPSS satellites. The imager on those is VIIRS, which provides higher spatial resolution imagery for forecasters. Roughly 375 meter to 750 meter resolution. And due to swath overlap, forecasters get more images from the VIIRS satellites over Alaska compared to a forecaster over the CONUS. And this is important because this chart shows as you move further away from the equator, the spatial resolution or the spatial footprint of a GOES pixel increases dramatically. So the GOES imagery becomes not as useful to non-existent closer to the poles once you get to northern Alaska poleward. But fortunately, they have VIIRS imagery to use up there, which has the high resolution and, again, swath overlap over northern Alaska. They'll get 16 to 18 passes a day from the 3 VIIRS. So this is the information we're taking to create various products for forecasters to view unique atmospheric phenomena. So now with blowing snow, of course, blowing snow can dramatically reduce visibility very near the surface very quickly from clear skies, unlimited visibility to below a mile very quickly. And as you know, that's a significant hazard to aviation and transportation. Traditionally, and this is relevant for forecasters in the Weather Service, they'll issue forecasts for blowing snow. They'll issue a blizzard warning for blowing snow conditions. Of course, in the Weather Service's forecasts of aviation, they're concerned with blowing snow, reducing visibility at an aviation site. So they want to know where blowing snow is happening, certainly. Radar, isn't really, radar detects precipitation, not really blowing snow. And when I talk about blowing snow, we could kind of get into some semantics of what exactly is blowing snow, but what I'm talking about is snow, loose snow, fresh snow that's on the surface that's getting lofted up, meters and meters lofted up into the lower atmosphere. Drifting snow is another name. Drifting snow is really usually just snow in the lowest couple feet. We're talking about blowing snow that, again, is being lofted meters upon meters up into the atmosphere. So we're not, in this case, talking about snow that's falling, actively falling, but again, it's on the surface getting lofted up. And this is what Weather Service is concerned with, is they're going to issue all these products. Historically, what they'd use to detect blowing snow and acknowledge what is that's there are observations outside of satellites. So things like law enforcement telling them it's there, webcams, especially recently, the public calling in and telling them, or contacting them on social media. But we've been, again, we have these relatively new satellites giving us higher resolution imagery, and we found that we can actually see signals in the imagery that blowing snow is happening. We need clear skies, of course. We can't see through the clouds with these IR invisible satellite. So it's blowing snow that's happening in the clear sky, and we're basically combining various channels from these satellites to highlight a blowing snow signal. So really quickly with what it is and some examples, the GOES imager has 16 channels and VIIRS has 22. And with these relatively new, now decade-old satellites, we knew this is a lot of information for forecasters to have, and to best highlight features, forecasters are no longer looking at just single channels alone. What we're doing is combining channels from these satellites into multispectral imagery products to tease out features. So we use basically characteristics of certain channels to better highlight certain features, so we could tailor imagery to highlight a given feature. So in this case, we developed this blowing snow RGB that through the combination of these 3 components, or it's actually 4 channels, to create a blowing snow imagery product. And this is one of those, it's a subtle feature, kind of like what we did with sea spray and blowing dust. It's fairly subtle, so it really takes training and forecaster understanding of what to look at. But we are able to highlight what we've come to know is a signal associated with blowing snow. And in this example over northern Alaska, you can see the blowing snow. Typically, depending on how dense the blowing snow is and the background conditions, time of day, the appearance could vary, but usually it's this lighter pink to sometimes bright green color against the red background, and the red is going to be snow cover. And then your blowing snow is this lighter pink or green. Clouds are these blues to purples. So that's what it is, and forecasters now have this product to detect blowing snow. Whenever we're developing a product like this, whether it be for sea spray or blowing dust or blowing snow, we need to know that what we're seeing in the satellite is actually blowing snow. That's a part of the research and what went into the development of this paper and continued refinement of these products. And blowing snow is very new, so we're still kind of learning about it. But so what do we use? We use those surface observations like ASOS stations. Oftentimes they're augmented with weather observer reports that'll confirm that it was blowing snow. Otherwise, you'll look at visibility. Maybe you don't have clouds, then visibility reduces. That's probably due to blowing snow if there's snow on the ground. We use high resolution satellite imagery like Sentinel. It gives us 10-meter resolution imagery, so we could really get in to confirm the presence of blowing snow. Webcams, again, a lot of the state Department of Transportations have good webcam networks that we use to confirm what we're seeing in the imagery is blowing snow. And finally, photographs, usually from social media or folks like Carl Durking. But if we could have more photographs, outside of the major highway networks where you have webcams, to again help us confirm where blowing snow is occurring in Alaska, but also in the northern plains of the United States, that would greatly help our validation of products like this RGB. So just a couple quick examples. This is over North Dakota. You can see the clouds as like the whites and blues and purples, and then these streaks are basically features that are associated with blowing snow at the surface. Very widespread from northwest to southeast across North Dakota on this day, and the GOES imagery on the left, and then the higher resolution VIIRS, which allows us to focus even closer in on these features. Oftentimes they might be this narrow plume producing blowing snow at the surface. So you might have visibility less than a quarter of a mile in one area, then 1 mile to the east, you might have perfect visibility. So to be able to have photographs or observations of what's actually occurring underneath the plume is really important. Here's another example over southeast South Dakota. You can see not as widespread these plumes and oftentimes occurring between surface observations. So again, if you could get a photograph or a webcam in there, that would be important for us in our continued development of the product. Here's a case in Kansas where we had a colleague at Zoke driving through Kansas on this day. Essentially at the surface, you had these streaks of areas of blowing snow moving from north to south, especially later in the animation. Right there, the more subtle looking streaks, not the bright colors, but the more subtle looking pink to usually pink. It really helps towards sunset to see the shadows of these plumes. Again, these are only maybe meters, tens of meters into the vertical of these features. These are actually horizontal convective rolls that are associated with blowing snow at the surface. And Ed Zoke was actually driving through them, and at times you can see they're fairly shallow. Some might be deeper than others, but this is the kind of thing that we're able to see in our satellite imagery, and you can see causing transportation issues. Over northern Alaska, this is a good case of blowing snow across the northern tier. You can see in the GOES imagery, it's really hard to see once you get this far from the satellite subpoint, and that's why VIIRS is so important. You can see in the VIIRS animation, you have this clear, again, depending on the viewing angle of the satellite and time of day, bright green to pink, sometimes streaks from east to west. And with this case, there were some FAA webcams where we were able to confirm. We know there's no clouds based on satellite, but we see this feature. Is it a cloud? What is it? We could confirm that there was blowing snow at those two sites. And then one more example from western Alaska this time. Again, GOES imagery not as clear, but the VIIRS imagery provides a nice view. And at this location in western Alaska, a webcam, again, confirming low visibility. So you could see the importance of having these photos or webcams and knowing what we're looking at. And just wanted to quick show a sea spray example. This was the famed Carl Dürking photo. You could see the choppy waters and the haziness above the surface associated with sea spray. This is an even more subtle feature than blowing snow, but using photographs and other photos from webcams, high-resolution sentinel imagery, we could confirm and create this product where you can highlight sea spray over open waters and clear skies. And in this RGB, it's this kind of lighter cyan compared to an icy strait where you have calm waters, this very dark color. You can see another streak coming out down here. Then one more example of blowing dust, because I know you guys do blowing dust as well. We're also continuously developing and refining products to detect blowing dust for similar reasons. Dramatically reduces visibility, significant hazard Weather Service is concerned with. You could see a photo on the bottom left of a haboob or a leading edge of a blowing dust plume. Again, we're using photographs, high resolution imagery here to confirm our satellite products are picking up on blowing dust. So that's what I have. Again, we're combining channels from these satellites to detect these subtle near surface features that are otherwise very hard to detect in other products. But in order to know that we are detecting the right features, or maybe using photos and webcams to confirm that blowing snow is occurring in areas that we can't see in satellite. Maybe there's events occurring and our satellites just don't have enough detail to pick them up. That's also important. And that's why photographs from this type of project would help us. So ground truth, really important in providing the best products for our end users.
So one of the key messages from Bill Line that you just heard is that a single photo can make a difference. I just want to restate that all the people who are doing Globe Observer and taking those photos of the sky or the ground, just a single photo really truly can make a difference. And I put in the chat, Carl Dierking, his photo of sea spray is what really led to this conversation with Bill Line about, could you also get photos of blowing snow? So we're going to have some breakout rooms, and I first want to very quickly introduce the Director of Geographic Information Network of Alaska, who will be in the blowing snow breakout room. And she can, because Bill wasn't here today, Jen can very quickly just restate some key nuggets of how we do this satellite remote sensing using both GOES and VEERS.
Hi, Christy. Thanks for the introduction. This is really my first foray into the globe world, so I'm very excited to be part of this activity. One of GINA's main mission is to deliver near real-time or really fast satellite data from the VEERS instrument to our partners across Alaska, including the National Weather Service. We have 3 antennas that sit here in interior Alaska receiving the NOAA satellite data as they fly overhead. So this is a really exciting opportunity to help validate an innovative product developed by Bill Line for blowing snow with VEERS. And we're excited for this opportunity. Christy, we're available to work with any patrons from Globe that have questions about this activity or the products. So thank you very much.
Yeah, thank you, Jen. So now we're going to have 2 different breakout rooms. We have X snow and we have blowing snow. X snow is snow that's on the ground, and it's mostly in the East Coast where there's actually a lack of data. A lot of the data has been collected from citizen science across the Western United States. And then we have blowing snow, and we are wanting photos using the Globe Observer Cloud's new feature photo tool for blowing snow, and we do want those from all over the world. So we have some key questions. We hope that people can go into both breakout rooms, but the questions are basically the same. First of all, what would your motivation be for joining these 2 programs in collecting X snow or blowing snow observations? Second of all, how do the observations from volunteers actually get used? So Marco, maybe, if it comes up in your discussions, how would you actually use the observations that people are collecting? And likewise, Jen just said how we would use for validation of the blowing snow product. It can be used for forecasting and weather alerts. And I also want to shout out that Globe builds community as well. Our third question is, so you've done an observation. How do you see it once they've been submitted? So the people from the Globe Observer team, I see many of you here, and Becky Boger from Director of STEPI, Science Training Education Public Engagement with Globe is here as well. Like, we can share how people can get the data once it's been submitted. And then lastly, how can we help? Let's do Globe together, and let's get snow both that's lifted high off the ground and on the ground. So those are the 4 Q&A questions. Thanks for putting them in the chat, Jackie, and the Globe Implementation Office team there. And let's go ahead and break into our blowing snow and our X-Snow
Christy,
breakout rooms. Yeah.
really quickly, because we're short on time, we're only going to have about 8 or 9 minutes in these breakout rooms. So I put in the chat also a link to a Padlet. Please add anything we don't get around to discussing, just for everyone, add anything to the Padlet. Our team will regroup after this and think about some next steps for continuing this conversation. So I think with that, we can jump into the breakout rooms.
Civil Air Patrol can participate pending permissions.
I have got you one region. We are working on getting you the second region. So it looks like you will have Colorado, Wyoming, Montana for sure. We're working on getting you parts of Idaho. And then we're working this weekend on confirming the Great Plains states. So Dakotas into Minnesota on down to at least Nebraska. So that should give you a reasonable swath.
I'm really curious about this one in that some of the other things we've done with Civil Air Patrol and other Globe campaigns, they're easy things to capture because easy in that it's there. You're going out, you're measuring what's there when you're there at the scheduled date, time, location, go do it. Blowing snow is just something you report when you see, and that's a really different type of thing to plan around and try to recruit people to participate. And I'd love to hear what folks think about that. We've tried with the dust thing, and we just really haven't really had a lot of success there. I'd love to hear what you think.
So we are kind of leveraging the same type of quick response that we are using in support of the Aurora Watch mission. So that is where they're actively putting alerts in and we're watching for a particular phenomenon. And so we've been talking about this internally, and we're looking at having them watch for when the wind hits a certain threshold. So predicted winds hit a particular threshold. That is when they're on alert to possibly make observations. So in this case, we'll probably be giving a chunk of null observations on when wind hits particular thresholds.
And that's great.
So you'll have both null and
yes,
and actual.
Zeros are important as well as the active ones. And yeah, using the forecasts. Blowing snow is something that can be forecasted up to a point. So yeah, that's exciting, Captain Bab.
Yeah.
Makes me wonder if we could do that. I mean, I think Civil Air Patrol is the perfect community to test this with, but I also wonder if we could develop something a little more sophisticated where you look at the forecast and say, okay, for this geofence region, we expect to see snow. And so we send out like in-app alerts and say, hey, it looks like you're going to have wind in your area. I mean, that's going to take a fair amount of work, but that could be an interesting approach.
Yeah, but Bill, and we also have somebody, ERT at Noah Nestis and Star, who sees on the backside of these probably. Thanks for coming. But yeah, once either wind, we are predicting high winds, or we're predicting, there could be winds at the ground, but that's the thing that I'm learning from Bill with blowing snow is that you could be driving, say, for a family trip, a vacation, and it's totally clear and it's not windy, and you won't know that you're going to hit wind later on. So that's where, these paying attention to these National Weather Service forecasts and then being ready to collect observations, it made me need education about that.
Definitely.
Yet it won't necessarily, it would take a lot of work, I think, to do what you're calling the geofence.
Oh, it would take a lot of work.
Yeah. There's going to be wind, go out and put the bell on the Globe Observer app.
Right.
fell on to go have people observe. But Captain Bab, like you have people observing at regular times, so they'll now look for this.
So we'll be able to incorporate this type of program. The other thing is if this pilot works well, we may be able to tap into our communication networks and have people radio in observations and give units downwind the highlight of, hey, we've got this phenomenon happening. Next state over, keep your eye out.
Mm-hmm.
But that will be next stage of pilot.
And the other part of things that we talked about this summer is then how do we get to the people using the data? How does Globe and our infrastructure then get these observations pretty quickly? You know, and we talked about a Slack channel that maybe NOAA and NESDIS could have. We're working out that end of things. Once your observations come in, how to get them over.
Mm-hmm.
Do you have ideas on that one, Holly?
Oh, the only thing that comes to my mind is I know we're kind of testing some of those very similar things with the Skywarn community.
Skywarn, yes.
And so I suspect there are similar communication structures set up. Anyway, I know it's a different part of NOAA, so I don't know if it's the same. Anyway, but yeah.
Well, we can do a super.
Christy,
ahead,
sorry. Sorry, I'm kind of chilly. Tina Rogerson can pull data like she did for Ice on Ice.
Okay.
If that is, we are doing it for mappers. So kind of like a quick view of the data. Are people reporting it as an obscuration and then putting the picture? Is that how?
So there's two ways, and I have it mocked up for putting on the website as soon as the shutdown's over. It can go live. We want obscurations and we want clear sky, just like Captain Bab was talking about, of having people observe when you can't see the sky at all and it's blowing, or when it's clear and you see this wall of snow that's in the distance.
Some kind of data trigger for Tina to pick up on whether that's a comment.
Is it a comment?
A field note or something.
Yeah, blowing snow in the comment is kind of what we envisioned. But also if they hit in Globe Observer Clouds, if they click on blowing snow, that would automatically go. But if they
what Holly is saying, how do we pull the zero data?
Like data? You'd have to have that tag.
Like for us to just pull that and push it to a viewer for you all. Unless they report snow on the ground. I don't know.
Sorry for distracting everybody, but it's good to see people. I know Brian for a while. I mean, I basically was at Goddard Space Flight Center where Brian was during my postdoc. So it's been 25 years ago.
Yeah.
So could Exno protocols be part of? Sorry.
That's basically when I started, like 2001.
Yeah, I was there in 2002. Yeah. So could XNO be part of the Global Observer Tier 1 or Tier 2, as snow is currently in precipitation in the weather app and is separate? I want to express 30 seconds my opinion before everybody. So precipitation, definitely this is something that has been attempted in several proposals. I had a proposal with a colleague who unfortunately passed away a while ago, Gail Jackson, and she was the lead PI of the precipitation mission for NASA. And I think having a way to connect the precipitation, because also even within NASA, the satellite products of precipitation and snow on ground are completely separated. We try to merge them, but there's no really willingness to do that financial wise, and having some data sets that can start closing the mass budget of what is on the ground with what is falling will be incredibly important. And so I'm going to shut up. And of course, I think I would love the the XSNOW protocols to be part of the GlobeSNOW server protocol. And I'm happy to, as we were discussing with Christy and Jackie, to revise some of our metadata and data description so we can standardize everything, and we can also make everything more discoverable and make others discoverable to us, to our stakeholders. So I'm going to shut up. Sorry.
Under data entry, I mean, snowpack and stuff for trained people currently and potentially for anybody going forward, that is in there. I think to connect, to include the two parts of land cover, so you can make bundles that cross protocols. I think right now land cover isn't listed in the biosphere in the data entry. And I think there's some reasons for that, but I think that could be the way to do it. You can create a bundle that pulls from multiple spheres. We would just have to get land cover added to the biosphere the way clouds is, because then when you go through the protocols, if you do a bundle, it goes through the ones that are in data entry, then it'll pop you over to clouds to do the clouds observations and stuff. So yeah, I think that, and I don't remember exactly. There were reasons why land cover wasn't included on the list, but I think because maybe there's the biometry that are a little bit different, that are part of the trained part rather than the land cover. But yeah, I think that could be doable to make a bundle.
Yeah, no, and I think it's a great. This is exactly. I think these simple steps are going to make a huge difference, and the coordination of these steps is probably the hardest part, considering also the lack of funding. And I'm happy to to have this conversation so that we can actually make something happen globe-wise, but also within the U.S. with the U.S.-funded NASA project to try to make this happen. So my understanding is, Jackie and Chris, at some point you will come back with the synthesis of these conversations and break a room for me also to have some bullet points, so because we're recording this.
Yes, this is being
Okay.
recorded, so we can come back with some of this. And
Okay,
Becky,
thank you.
also, I wonder if you might want to address some of that too, because I think there might be room for more conversation. I know there is.
I had a question, and I've already been talking to Christy, and I'll get an update from Christy in terms of the SNOWX on the Globe Observer. Would there be a new data field that need to be created, or any new data field? And Christy, maybe you know the answer to that. Or is it using the existing data fields that we have?
I mean, we have snow depth, and we have the ability to calculate snow water equivalent. I mean, that's already something that's a GLOBE protocol. I did look through some of the materials about XSNOW. I didn't compare it side to side with the existing GLOBE protocols. I mean, but there are GLOBE snow protocols, and I think at first glance it didn't look significantly different for what the XSNOW was asking. I mean, some of the stuff that XSNOW is asking is different, like the photographs of the snowflakes and things like that. But it didn't look significantly different to me for most of it. And for the photographs and things, we have ways to accept photographs. We just haven't had people. I mean, besides Brian's wife, Jen, who does amazing snowflake photos, that's not a GLOBE, that hasn't been a GLOBE protocol before.
Okay, great. Yeah, I know that Christy's been working on the snow and making some modifications or clarifications, if nothing else, on the existing GLOBE materials to be more in line with NASA's snow classifications, or what types of data are being collected. I think it would be great to have this on the GLOBE Observer. I think it would be wonderful.
Well, and I think the thing is that that a lot of it, again, it's not exact. I don't know that it's exactly the same, but I think it's substantially similar in terms of the data that we're asking for. We just have to sit down and see, are there any particular differences, and are those differences going to be a problem?
Yeah. Marco,
it's really
question.
already there. It's just a question of who has access to it,
Yep.
because right now you have to go into data entry and you have to go into precipitation, and then
Right.
once you pick precipitation, then it asks you, are you doing rainfall, snowfall, like new snowfall, snowpack? So, you do have to go through a few steps to get to it.
Yeah. Well, I guess we're going to be leaving. We certainly don't have much time.
Yeah, unfortunately. But I think that I see this as planting the seed for more conversation and more connection. And I think Becky, Kristen, and with Christy, we can figure out some of those next steps, and we will have a recording for this session, and we'll work on synthesizing some of the ideas. And for everybody, please feel free to add anything more that we haven't gotten to the Padlet, any other ideas. And yeah, Marco will definitely be in more conversation with your team. Go ahead.
Hopefully, 15 seconds. Hopefully, we can find a way to justify international funding support to organize and homogenize everything under the snow umbrella, given its importance. I think that would be nice to find donors, private donors in America.
Yeah. Pretty much out of time. I just wanted to really quickly mention two things. Carol, next slide, please. Again, a reminder that we have some more learning sessions coming up, and we will definitely circle back to figure out what some of our next steps are around the snow protocols and around connecting with these two snow efforts. And next slide, please, Carol. And the last thing I wanted to mention, first of all, the Padlet was in the chat, so add any ideas or questions that remain to the Padlet. But also please add any of your feedback on this session as our team plans additional sessions. What else would you like to hear about? What went well today? And that sort of thing. So we have that feedback form as well. So thank you all for joining us. Thanks everyone for being here and for sticking with us for an extra moment. It's really been great to hear about these efforts and to think about how we can connect Globe to them.